Alright, Maths Apps 4, we now move on to the world of finance, and in particular loans, which you know about, and savings, investments, which is another word for savings, and annuities, which you may or may not have met before. The learning intention for this exercise, which is about nominal and effective interest rates, is to be able to explain nominal and effective interest rates and calculate them. Okay, we all know that money makes the world go round, so let's start by having a look at a song from the movie Cabaret.
Money. Money makes the world go around, the world go around, the world go around. Money makes the world go around, it makes the world go round. A mark, a yen, a buck, or a pound, a mark, a yen, a buck, or a pound is all that makes the world go around. The clinking, clanking sound that makes the world go round. Money, 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 money. If you happen to be rich and you feel like a nice entertainment, you can pay for a gay escapade. If you happen to be rich and alone and you need a companion, you can ring ting-a-ling for some mate. If you happen to be rich and you find you are left by your lover and you moan and you go quite a lot, you can take it on the chin, call a cab and begin to recover on your 14-carat yacht. What? Money makes the world go round, the world go round, the world go round. Money makes us go round, of that we both are sure on being poor. Money.
Well, there you go. If you want to see the whole thing, just search for Money Makes the World Go Round with Liza Minnelli and Joel Grey, one of my favourite films over the years. The whole basis of calculations of interest rates is what you already have met called compound interest. And compound interest rates are normally quoted as annual rates or rates per year, and that's what the bank will advertise. And the proper word for this is the nominal interest rate for whether it's a savings, an investment, or whether it's a loan. But what you also need to take into account when evaluating a rate is what is the time period of payments. Are they paid annually, as it seems to imply, or are they paid quarterly, 4 times a year, monthly, 12 times a year, fortnightly, quite often 26 times a year, and even daily, 365 times a year, which is what normally banks actually pay. At the end of each working day, they calculate the interest on the daily balance. There is a note at the bottom of that extract from the textbook which doesn't make any sense to me, so ignore it. A nominal interest rate is converted to a compounding interest rate by dividing by these numbers. Well, that's nonsense as it stands. Look at this table here. They've taken as an example an investment of $5,000 and a nominal rate of 4.8% a year. Now, if you look at the calculation on the first column, if you were paid 4.8% a year, you would get at the end of the year $240. But if they actually pay that rate quarterly, in other words, it's 1.2% each quarter, making a total of 4.8% over the year, as you can see, the interest is compounded, interest is on interest, and at the end of the year that way you would actually get 4.89%. You've actually earned 4.8.9%, not just 4.8. And then the last column, same thing again. If it was paid monthly, well, that would be 0.4% each month. That compounds up 12 times altogether, to giving you $245.35, $5 more than $240, and effectively that means that you're getting 4.91%, which is good news if it's an investment. Maybe not such good news if it's a borrowing. How do you calculate effective interest rates? Well, the textbook gives you 2 ways, and I invite you to ignore the first of them, which is to use this rather complex looking formula. It's there for you to look at. This is the sort of thing that is ideally suited to a function on the calculator or indeed on a spreadsheet, and that's what I'm going to show you how to do. So you need your graphics calculators. You may not have used this button before. It's the APPS apps key on your graphics calculator, somewhere in the middle top left area. If you select that, now you may have already got more than one app on your calculator. The one I'm showing you here is just got the one, Finance, so select Finance. These are a lot of financial calculations that you can do, which is the same as the ones you can do on a spreadsheet. We want number C, which you scroll down past 9A, 0ABC until you get to EFF, short for effective, and select that one. Alright, if you want to know what an effective rate of interest is given a nominal rate, you just need to tell the calculator what the nominal rate is and how often it is paid. So the first example here, we've got a nominal rate of 4.8%, comma 4, which means I want to know what that is when it's calculated quarterly. Close brackets, press enter, and we'll get you a 4.89% to 2 decimal places. Lower half of the screen has got the same thing for you to study for 12 times a year and 365 times a year. These are the same calculations as on the table on the previous page. So that's all you need to do to find an effective interest rate given a nominal interest rate. I've only selected one question from the textbook to have a look at. Questions 1 to 5 are basically just practicing that skill, which you should work through. But when you get to question 6, just look at this one here. We've got Luke considering a loan of $35,000, and his bank for some reason has 2 compound interest rate options. You can either have 8.3% compounded monthly, or you can have 7.8% compounded weekly. Now, why they would offer you 2 different rates and try and blind you with science is beyond me. They probably don't. But the way to compare them is quite simple. We put into the calculator 8.3, 12, which will give us 8.62, and we put in 7.8, 52, close brackets, for 8.11%, as you can see on the answers on the bottom right. And that's the effective interest rates for the 2 loans. Part B, the amount of interest Luke would pay. Well, obviously on the first one he's going to pay more, $3,017, and first one you go 35,000 times 1.0862, which will give you $3,017, and the second one you go 35,000 times 1.0811, and that will give you 283850. So those are the 2 amounts of interest. That's the difference that the loan will cost you depending on which one you take, and obviously Luke should choose the cheaper one, B. There you are. Now you know, if you follow that, how to calculate nominal and effective interest rates and explain them.